Swagatam in computer learning series, that is seeing the beautiful sights of greeny Indian village and learning computer and enjoying it. This will give you the peace of mind. The greeny sights gives peace in mind. So again, I am with some topics in lecture. Modems. In this we will explain about modems. So let's see first. There will be another topic also, but see first. Firstly, the modem. So modems communication system use a special device called modulator or demodulator to perform modulation and demodulation, that is conversion of digital data to an analog form and vice versa. Hence, when a data communication system uses an analog facility for data transmission between two digital devices, say two computers interconnected by a telephone line, it requires two modems, one near each device. When sender's computer generates and sends digital signal, modulator of modem placed near sender's computer convert it to analog form. The computer system then transmits this analog signal through telephone line up to the modem near receiver's computer. The demodulator of this modem then converts analog signal to digital form and passes on the digital data to receiver computers. The receiver computer processes the data and then the modulator of the modem near it modulates the processed data to analog form. The communication system returns this analog data through telephone line to the sender computer end, where the demodulator of the modem near it demodulates along signals to digital form and then passes the digital data to sender's computer. Hence, modem is an essential piece of hardware for any application in which two digital devices want to communicate over an analog transmission channel like telephone line. When a user wants to use a modem, he should consider the following factors. First, transmission speed. A modem having higher transmission speed can communicate faster. Transmission speeds of earlier modems were 300, 1200 or 2400 bps, whereas modern modems can operate at 9600 or 40,400 or 28,800 bps, that is bits per second. Next is the facsimile facility. Facsimile facility. Some modems known as fax modems can function as both a fax machine and a modem. A computer with a fax modem can send or receive text and image as a fax to either a remote fax machine or another computer with a fax modem. Fax modems can be of external or internal type. Next factor is internal versus external. Modems are of two kinds, internal and external, An internal modem is an optional add-on circuit board that plugs into one of computer's expansion slot. It gets its power from computer's expansion bus. Computer manufacturers manufacture and supply such modem with their computers. An external modem, on the other hand, is a separate box containing circuitry and logic to modulate data signal. It has its own power supply, on and off switch, and front panel LCD to indicate its status. For this reason, external modems are slightly more expensive. An external modem is connected to a computer via serial port. Now the next factor regarding modem is error correction. Data transmission error may occur while data moves on telephone lines from one modem to another. Some modems use method of recovering from data transmission errors. Two standard methods protocol which these modems use for error correction features are CAP MNP4 Microcom Network Protocol version 4, developed by Microcom Inc. and V.42 standard developed by CCITT. MNP4 error correction protocol is suitable for low speed modems such as those operating at 2400 baud, whereas V.42 standard is suitable for higher speed modems, that is those operating at 9600 bps or 40,400 bauds. The next point is data compression. Data compression techniques help in reducing the volume of data. The amount of reduction depends on the kind of data and the comparison algorithm used, but can be as high as 10:1 ratio. Modems with built-in data compression techniques have higher throughput, can transfer more data in same amount of time than conventional modems with same speed. Now we see the analogous versus digital transmission. So what in this in analog and versus digital transmission? Analog signals become weak and distorted when they travel long distances. Hence, communication systems which transmit analog signals use amplifiers at periodic intervals along communication lines between modems to amplify weak analog signals. And the communication system which transmit digital signal do not need modems. They use repeaters at a periodic interval along communication lines to strengthen digital signal which become weak due to long distance travel. And now digital data transmission is preferred to analog data transmission because of this reason. Digital transmission is low cost, it has no modem, this not requires an modem, and has higher transmission speed and lower error rate, that is higher reliability. Now we see the data transmission services, how data transmission services is done. So let's discuss this. So what is the data transmission services? A data transmission path between two computers located far away from each other involves multiple data transmission media such as copper wire, fiber optic cable, and communication satellite. Organizations can afford to lay their own communication channels in a smaller geographical area, such as within a building or campus. However, they find it impractical to do so in a large geographical area, such as between two cities or countries. It is also impractical for them to set up their own satellite in orbit. Therefore, organizations hire services of data transmission service providers, known as common carriers, for their data communication needs. BSNL, that is Videsh Sanchar Nigam Limited, and BSNL Bharat Sanchar Nigam Limited, and MTNL Mahanagar Telephone Nigam Limited are the few such common carriers in India, whereas AT&T, MCI, Western Union, and GTE are a few such common carriers in United States of America. Typically, common carriers offer following types of services. First one is dial-up line. Dial-up line, also known as switched line, service operates like a telephone service. A computer user willing to communicate with a remote computer first make a connection request by dialing up the remote computer. The communication system then establishes a circuit between the two computers via telephone company's switching system. Modems attached to the computers then send and receive data over telephone line. Like a telephone call, charge for data transmission service in this case depends on duration of communication, that is circuit establishment, and distance between the two computers. Next service is leased line service. Leased line, also known as private line or dedicated line, is a special conditioned telephone line connecting two computers or two line terminating equipment like routers directly and permanently. It can transmit both voice and data. Hence, if an organization has two offices in two different cities, it is often cheaper for the organization to have its own leased line between two offices for all its voice and data transmission needs. Often charge for a leased line are based on channel capacity and distance. And the third service is integrated service digital network, abbreviated as CAP ISDN, integrated services digital network. The ISDN is a telephonic system providing digital telephone and data services, as it supports digital services including digitized voice, integrated service digital network. Telephone users enjoy noise-free CD quality sound. Moreover, integrated services digital network does not require modems because it supports digital transmission of all types of data including voice. This also results in a very short call setup time between two ISDN subscribers. Main factors that led to the development of ISDN are Adoption of digital transmission by many public telephone systems. Such networks encode voice traffic using pulse code modulation at 64 kilobit per second. These networks can carry data also, resulting in an integrated digital network IDN, abbreviated as IDN, CAP IDN. Based on transmission and switching capabilities, the ISDN are currently of two types: narrowband integrated service digital network and broadband integrated service digital network ISDN. Narrowband ISDN uses multiple 64 kilobit per second bit streams and combines them into higher capacity trunks using time division multiplexing. For example, a communication system can combine 32 64 kilobit per second channels to create a 1 2 megabit per second channel. A narrowband ISDN, however, cannot support requirements of several types of data services, usually those needed for multimedia applications. For example, bandwidth required for full definition digital video is about 100 Mbps to handle this type of traffic, as well as burst of data traffic from computers. Communication system designer introduced broadband ISDN, often referred to as BISDN. BISDN uses optical fibers and asynchronous time division multiplexing. Advantage of asynchronous time division multiplexing over conventional time division multiplication is that it allows the total bandwidth available to be divided among contending activities in much more flexible way. Integrated service digital network has become so popular that users and service providers have coined the term plain old telephone service, POTS, POTS, plain old telephone service, to describe a standard analog service. The fourth one is value added network WAN, abbreviated as VAN, VAN. Some companies specialize in providing value added data transmission service over and above the standard service of common carriers. Value added service includes electronic mail, data encryption, decryption, access to commercial database, and code conversion for communication system between incompatible computers. Normally, these companies take dedicated lines of a common carrier on long term lease, do value addition to enhance communication facilities, and then sell the enhanced services to users. This type of service is known as value added network WAN service. So, this is a brief discussion about data transmission services. Now let's see about the multiplexing techniques. Often several user terminals are connected to same computer. If each terminal operates at 300 baud over a communication line operating at 9600 bps, we see a very inefficient operation. A communication channel is an expensive resource, and transmission capacity of a channel normally exceeds much beyond the requirement of a single user. Hence, for optimal utilization, a channel can be shared among multiple users by transmitting multiple signals simultaneously through it. The method of dividing a physical channel into multiple logical channels to transmit a number of independent signals simultaneously through it is known as multiplexing. The electronic device that performs this task is known as multiplexer. A multiplexer converts several data communication lines or signals into one data communication line or signal at the sending end. The communication system multiplies signal from 4 terminal to into one large signal for transmission through one communication line and breaks the large signal into four original signals at receiving end. Without multiplexer, four separate communication lines would be required. Hence, multiplexing enables a single transmission medium to transmit data of several transmitters and receivers currently. The two basic methods of multiplexing channels are frequency division multiplexing and time division multiplexing. So let's see first frequency division multiplexing. What is uh, frequency division multiplexing, also abbreviated as FDM, frequency division multiplexing? It divides the available bandwidth of a physical medium into several smaller disjoint logical bandwidth, each of which serves as a separate communication line. Radio broadcast technologies uses frequency division multiplexing to support multiple radio stations simultaneously. It assigns a different frequency range within a bandwidth of radio frequency to each radio station. Several radio stations transmit a speech signal simultaneously over physical channel ether, which is an invisible, ever-present and unprovable medium through which waves travels, propagate in space. A radio receiver antenna receives signals transmitted by all stations, and a radio set uses a tuning dial to isolate signals of the station tuned. A frequency division multiplexer can deal with only analog signals. A digital communication system using FDM must convert digital signal to analog form. Now, second one is the time division multiplexing, TDM, abbreviated as TDM. TDM, it divides total time available in a channel among several users and allows a time slice, a short time interval, to each user of the channel during which he may transmit a message. In this way, TDM interleaves multiple data stream of different users into one data stream at sender end of the channel. At receiver end, a demultiplexer resembles individual chunks of message into full message of different users. TDM process by multiplexing three different signals. The same idea may be extended for multiplexing several signals. Although TDM can multiplex either digital and analog signal, it is more suitable for digital data transmission. It is also suitable for communication between computers because computers communicate in short, fast bursts. Moreover, TDM is efficient because it enables network designer to derive more sub-channels. It is up to network designer to allocate time slot to different channels. It is common to have 32 low-speed terminals connected to one high-speed line. So, multiplexing is cost-effective when channel cost is high due to long distances. However, a drawback of multiplexing is that if a multiplexed line fails, it affects all users sharing it. Failure of an individual channel is likely to affect one user's only. Failure of an individual non-multiplexed channel is likely to affect only one users. So with this, I would like to end this lecture here.